Hello everyone, welcome back to my channel. Now this problem is belonging to the topic of electrochemistry. So to solve this problem, we require two understandings. One is regarding the redox balancing, that is how to balance the redox reaction. The second thing we should know that how to apply the Nernst equation, right? So let's directly dive into the question and understand how to solve it. The question says we are given a copper and it reduces nitrate ion into nitric oxide and NO2, and it depends upon the concentration of nitric acid in the solution, right? Assuming initially we are given copper Cu2 plus ion to be 0.1 molar and the pressure of NO and NO2 to be 10 raised to the power minus 3 bar. This is the data which is given to us. The question is asking us that at what concentration of nitric acid the thermodynamic tendency for the reduction of nitrate ion into nitric oxide and nitrogen dioxide by copper is same, right? That means what is the concentration of nitric acid which is asked from us, at what concentration of nitric acid the tendency of nitrate ion to get reduced into NO is equal to tendency of nitrate ion to get reduced into NO2. That means here the reduction of nitrate ion is taking place into NO and NO2. So that means it is asking us that at what concentration E of NO3 minus to NO equals E of NO3 minus to NO2. Now we know E is what? E is a reduction potential, right? So the data further which is given to us is the standard reduction potential values of copper ion, nitrate ion into nitric oxide and nitrate ion into nitrogen dioxide. So we'll do one thing. Since we have to apply the Nernst equation and we know the Nernst equation is applied only when the reactions are properly balanced. So we will try to balance the reactions. The first reaction is regarding the nitrate ion conversion into NO2, right? So if you look at this, since the reaction is taking place in acidic medium, we can easily balance it using the half reaction method. And once we have balanced it, we can see this is the reaction, right? Now in this reaction, we can find the Q1 because in the Nernst equation, in the term of log, right? What is the Nernst equation? Nernst equation is basically E is equal to E naught minus 0.059 upon N, where 0.059 can be taken as 0.06. And what is N? N is the N factor of equation, log of Q1, where Q1 is what? Or Q. Q is reaction quotient, right? So for the first reaction, what is the reaction quotient Q1? It is equal to product of partial pressure of NO2 divided by H plus square into nitrate ion. Now partial pressure of NO2, how much is given? 10 raised to the power minus 3 bar divided by H plus ion concentration N2 nitrate ion concentration. Now how much value it will be? Let's say in the solution we have Y moles of nitric acid, right? Here we have understand it. We have Y moles of nitric acid. Since nitric acid is a strong acid, so its dissociation will be very much high. That means alpha, that is degree of dissociation, will be nearly 1, right? So upon complete dissociation, what will happen? All of nitric acid will be dissociated into H plus ion and nitrate ion. Now since the stoichiometry is 1 is to 1 is to 1, that means if Y moles of nitric acid is taken, we will obtain Y moles of H plus ion and Y moles of nitrate ions, right? So in the solution, we can say on finding the Q1, partial pressure of NO2 is 10 raised to the power minus 3 bar divided by Y square into Y. So it is equal to 10 raised to the power minus 3 upon Y cube. Similarly, we can find Q2 also for the second reaction which is balanced, which is conversion of nitrate ion into nitric oxide. So upon complete balancing, we have obtained it here, and the Q2 will be equal to 10 raised to the power minus 3 upon Y raised to the power 4 into Y, which is equal to 10 raised to the power minus 3 upon Y raised to the power 5. Now since we have found the reaction quotient, now directly apply the Nernst equation, right? Because we know that the thermodynamic tendency of the reaction 1 and 2 is same, so this is what we need to find. Now E is equal to E naught minus 0.06 upon N factor log of Q, right? for the conversion of nitrate ion into nitric oxide, the n factor is how much? 3. 3 is the n factor. So here we have put the 3 is equal to ERP of nitrate ion to NO2 minus 0.06 divided by n factor. Here the n factor is how much? 1, and the reaction quotient is Q1, right? So this is where we have reached finally. Now the SRP values of both half cells is given to us. This is given to be 0.96 and this is given to be 0.79. So this is where we have reached 0.96 minus 0.06 log of Q2 raised to power 1 by 3. Okay, why we have done this thing? To simplify the calculation. Since it is basically what? It is basically 1 by 3, right? So we can easily take it into the power of Q2, right? Now upon further solving, we have reached at this step. So if we further solve it, it will come out to be 0.17 is equal to 0.06 log of, now Q2 is given to us as 10 raised to power minus 3 by 5. So since it is 1 by 3 power, so it will be 10 raised to power minus 3 by 3 upon 10 raised to power 5 by 3. And Q1 is given to us as 10 raised to power minus 3 upon y cube. So 10 raised to power minus 3 and y cube. This is how we put the values. On further solving it, it will be 17 upon 6 equals log of, this will be how much? It will be 10 raised to power 2 into y raised to power, basically this is not 10, this is y, right? So y raised to power 4 by 3. On further solving it, 17 by 6 equals, it will be 2 plus log of y. Since power of y is 4 by 3, I can directly take it ahead and it will can come here. So this will be equal to how much? It will be 17 minus 12 upon 6, right? Multiplied by 3 divided by 4 equals log of y. So this is how much? This is 5 by 6 into 3 by 4. 2, this is comes out to be 5 by 8, which is equal to how much? Log of y. So if you take the anti-log of this term, the y will come out to be 10 raised to power 0.625, right? And y was what? Y was the concentration of nitric acid which we had taken initially. So let's check if any option matches here or it comes out to be nearby. So here option C is the correct answer, which is totally or nearly correct to our value. So this is how we can easily solve this problem. The important thing regarding solving this problem is to understand how the application of Nernst equation and redox balancing has been utilized here, right? So for the further more problems regarding the electrochemistry, keep on watching the channel and keep on watching and keep on getting updates regarding the further questions. See you tomorrow.